Okay, thank you very much for the kind introduction. I've been here, I think it was a month ago, 2 months ago, there was another event where I also presented more or less in the same type of topic, but it's a different audience. Although the audience was also very much in the banking sector, so it looks like this kind of event is really focused on financial services and banking, which is fantastic. It was one of the industries that we are also very focused on and very interested. So we can keep this very interactive. I'm going to go through this presentation. I believe we've got time until 9:30. Is that right? Great. So okay, and so we can ask questions and so forth. So what I'm going to talk about is really about how do we talk about AI. There's a lot of hype around artificial intelligence and data science and IoT and big data analytics. But the big question is, how do you truly operationalize? How do you create those end-to-end solutions that's really plugged in and actually makes an impact and actually make an impact in terms of the value drivers of the business? So why do you need technology and smart technologies? It still needs to serve the business and it needs to make an impact. Now the good news is it can, and if you apply it in the right way. So but before I go there, I just want to quickly introduce Cortex, and I'm going to actually start with the smart. We live in a new era as well, so I'll frame it in that sense as well. So from a Cortex Logic side, what is Cortex Logic? We are a next generation AI company. We're an AI engine for platform businesses that's disrupting the market, but we're also helping corporates and enterprises thrive in this era because that's exactly what's needed. We see companies like Kodak, for instance, not with us anymore, and there is a lot of disruption happening, and I think it's very important that corporates and enterprises are actually making sure that they are agile enough to actually take advantages of what's happening in the smart technology era. If you're in a good position, you want to actually make sure that you are well entrenched. So there's a little bit of that. So what we do is to help companies from that perspective, and that is just summarizing it. And for me, if you look at any of these applications, it could be broken down into 3 areas. Artificial intelligence, data science, IoT, all of that is very, very dependent on proper data. You need to have a solid data foundation. You need rapid access to all available data, structured, unstructured, IoT, all of it. So I think that foundation, if a company doesn't have that sorted out, that should be a high focus, because it's going to serve a range of use cases and business cases. So what I talk about here is enabling smart data for automated AI, and I'm actually stating kind of an end state for each, because you can't automate if you don't have access to the data. You can't automate the data preparation, you can't automate the data science, you can't have real-time machine learning if you don't have the data sorted out. So that is critical. Then with the machine learning AI, we want to automate, and then you want to integrate that into the business. So into the workflows, into the business processes, into your intelligent virtual assistants. That intelligent virtual assistants needs to actually give feedback, well, that sentiment analysis and things that you do needs to go back to the data lake, to the data warehouses, so that you can actually use that information to inform your predictive models as well. So it's really creating this kind of closed loop type of scenario. Now, if you look at the industrial space, what you see there is things like advanced process control applications, or where you actually have models that's representative of processes, manufacturing processes, chemical processes, all sorts of things, or models of pieces of expensive equipment like furnaces and those type of things. And what they typically do in that environment is you build models that represent the reality there, and you take that and you actually have the models right back to the systems, to the operators, to production systems, to the workflow processes, so that you can say, if there's a runaway temperature in the oven, that you actually instruct the operator, this is what you need to do, or more, you actually give alerts. And you go as far as doing advanced process control, where you write back to controllers to actually optimize it. Now you can take that, and you can actually apply that now to the consumer-facing businesses, because we do have, I think people are becoming instrumented. We've got cell phones. You can do all sorts of things. People want on-demand, personalized services, and And I think this is not possible. And this is like real time, there's a real time need. And the previous speakers also talked about the real need to actually to quicken, to improve, to fast track your analytics so you can actually do things in real time. But this is exactly what's needed. This is the world that we work, that we move towards. So I think the integration of AI into the business is a critical, absolute critical factor. So just to quickly frame things from a era perspective. I don't know if you heard about the fourth industrial revolution. Right. So I just call it the smart technology era because it's not just industrial. It's really impacting all disciplines. And my personal massive transformative purpose of business and everything is how can we shape a better future for business, for people, for society in this new era. And if you think about the fourth industrial era, it's quite dramatic. It's different to the previous revolutions. It is fundamentally changing the way we live, we interact, and all that. But it's also a fusion of not just AI, but other new technologies as well, and it's blurring the lines between the physical world, the biological worlds, and the digital world. And it's really impacting all disciplines and economies. And as humans, we perceive things in linear time. We see everything linear, but there are exponential forces at work. And I actually have this slide just illustrating that. Where you see the speed of technology change in the smart technology era. You see a list of smart technologies, and you see now the fusion of these technologies to create new applications. So there's great opportunities, great challenges, and it's all up for us to utilize in a proper way. And this is what we need to deal with. And we also see these kind of fusion of new technologies already happening. We see software that translates and invests. We see self-driving cars, drones, kind of surprised by that. If you think about, I don't know who've heard about the game Go. Yeah. Okay, Go. So some people. So it's a very complicated. Well, in terms of the number of moves, it's a game like chess, except that you've got a bit more pieces on that board, and the number of moves that you can make on that board is more than the atoms in the universe. So you can't really search for the solutions. You need to actually train the system to actually learn this. And they've used deep reinforcement learning, one of the AI techniques, along with Monte Carlo search, and they've created a system that can create superhuman performance in terms of figuring out strategies and actually beating people and the best players in the world in that game. Which is dramatically different to just chess, where it's just more like a search base. You can just go with search, and you can pretty much do that. So those are the types of technologies that's coming to the fore, and you can apply that for other things as well, value chain optimization, or anywhere where you want to optimize. You just need to frame the problem properly. So you will see more and more of this happening at an increasing speed. You see also discovering new drugs, and you see also things like predicting cultural interests and stuff. So it's all a matter of making the data available, framing the problems in the right way, and then you can do magic. You can do unbelievable stuff. So that is just to set the scene briefly. Just in terms of the era that we live in, this is Professor Klaus Schwab. He's the founder of the World Economic Forum, and he was saying in the new world, it's not the big fish that eats the small fish, but it's the fast fish that eats the slow fish. And this is absolutely true. Even if you're incumbent, you're the market leader, you can't rest on your laurels. Things are happening very, very quickly, and one needs to be agile. And this is just, I think, what's going to be important as well. If you look at this, on the y-axis, it speaks of innovation. On the x-axis, we talk about collaboration. And this was, I think it was done by Accenture. And they've evaluated a number of companies. And most companies are really in this bracket, observers, where they're not really innovating, they're not really collaborating in an optimal way. And if you want to move quickly and fast, you want to be in that top right quadrant, collaborative inventor. So basically, partner with other companies helping you to accelerate and looking at other ways to monetize as well. Well, there's plenty. If you've got access to data, data's the new oil, there's opportunities to enhance, enrich this with maybe other companies' data, there's ways to work. You can work with AI companies that's helping you to accelerate things as well. But I think it's very important to be agile, and the way to do that is collaborative innovation. Okay, so we heard about AI, the new electricity, and all sorts of things. Just very briefly, if you think about AI being applied, the way I'm looking at AI anyway, there's multiple use cases for AI. First of all, we obviously want a 360-degree view of your customer. So you can apply AI on just uncovering hidden insights. There was one absolute area where we can do this. And that toolbox, the AI toolbox, has been enriched tremendously the last decade. The ability to work not only with structured data, but now with unstructured data. That means text, video, audio, sensor information, that is all possible now. But there's other applications of AI as well, in terms of the human-computer interface. I would say a few years ago it was not really possible to create really, truly great, impactful, intelligent virtual assistants or advisors. Now it's possible. And I've heard the previous speakers also talk about training and all of those type of things. I absolutely agree. It takes time. Obviously, the context is very important. It's also important what you also bring into it. If you look at tone and sentiment and all sorts of different things. But the whole AI tool stack around this are developing at an incredible fast rate. So we for instance, we've got joint business relationships with PwC, Deloitte. We help to operationalize AI for their customers as well. Obviously, working directly with customers, but we also work with the Microsoft, IBMs, and Googles. We use the Google TensorFlow stack, for instance, as well. But you see breakthroughs every quarter. So even the APIs that's available currently in IBM Watson Conversation Service or Microsoft Lewis or so forth is not necessarily state of the art. Well, there are things happening all the time. And I think we live in the API economy. It stands for Application Program Interface. And basically what it means is it's like Lego blocks. If you've got a state-of-the-art API that you can plug in that can make a big difference, you can bring it in. If there's a commercial API that's good, then you bring it in. If you've got your own proprietary things, you bring it in. And it's plug and play, and you create these end-to-end solutions. This is the world that we live in now. My previous AI company that I sold to General Electric, we wrote everything from scratch, C++, all the machine learning, all of that. The world that we live in now, if you want to move quickly, you have to look at open source, commercial APIs, your own stuff, plug it in, create end-to-end solutions that's integrated into the customer's environment. That's the way of the future, and that's the way how you can do things quickly as well, create those quick wins. So AI applications on the human-computer interface, but there's also on the data preparation front to create smart data. This is also what's interesting. We're also working currently with a company in the insurance industry. They've got, say, kind of scanned-in forms and so forth. There's technology available that you can actually take all of that unstructured data and create smart data. So if you think about call centers, for instance, if you think about recordings, you can take that recordings and you can actually listen to it. You can apply AI to that, and you can do sentiment analysis and all sorts of things on that. So you can actually work with unstructured data and create solutions. So you can see there's on multiple fronts, you see AI applications. And basically what you need is people that can actually know how to apply it and use it and creating those end-to-end solutions to create the value. Okay, I'm going to skip, maybe just the last thing here is, by the way, it's a little bit blurry, is it all right? Can you see? I wonder if one can't. You will probably further improve it, but anyway. Okay, so this is just showing. This was done by Bloomberg Beta 2015, and they've done it for 3 years. I think 2016, 17 as well. Creating kind of the AI landscape. I think the point here is just you see companies. If you think about enterprise, and you think about the various aspects of enterprise like sales, security, fraud detection, HR, marketing, etc. These companies coming with very specific, domain-specific, application-specific solutions around that as well. And you see industries, in each industry you see kind of AI applications as well, also on the human-computer interface. So there's a bunch of things happening here. with companies with focused solutions around this, and just showing what's happening in the space. So it's very, very aggressive. And this is 3.0. I think this was from last year. So things are exploding in that regard. Okay, so the rest of the presentation, what I would like to do is just go through more practical use cases. I'm actually going to show you a churn prediction, lapse prediction example, and I'm going to go through some use cases. But I think the message here is really how to become a data-driven, AI-first business in the smart technology era. I think that is absolutely of essence, and I think I've mentioned this before, having rapid access to all available structured and unstructured data, and then obviously you want to create end-to-end solutions that's fully integrated into the business. Doesn't matter what you do, you need to create that. You can't just come with a little subset thing here, a little data science exercise here. You think about what's those value drivers, business value drivers, and how do you actually build towards that, and how you can actually look at return on algorithms, or return on AI, or return on what you've developed here on the smart technology side. So this is, I think I mentioned this earlier, but data availability is really increasing at an exponential rate. Data utilization is still linear compared to that. So this is obviously due to IoT, more instrumentation, more social media, all of that. So that gap is increasing. So it's all up to us to actually say how can we utilize it in a proper way. So the way we look at these kind of solutions, and I talk about the AI engine, looking at those three pieces, there's many things that you can do to actually create valuable business cases for any business. So there's things that you can do to optimize a business. If you've got a business properly instrumented, then you can actually then you can start building models that represent that business as well. So for one of the customers, a big mining company, we're actually looking at the whole value chain, identifying all the data-driven opportunities. And the end state there would be to actually instrument that whole business, data points where you can actually build simulations. You can do what if scenario analysis and all sorts of different things, and even on that front, do things. But I think if you look at customer-facing businesses, it's really about a satisfied and growing customer base. So that's a very, very important area. Other areas for AI applications for employees, to help employees to be more productive, not waste time, to be more effective. We do have some solutions in that regard as well. And then I think also smart systems. If you think about fraud and cybersecurity, IoT, all of that, there's a bunch of things that one can do. So for me, it really starts with this, the value drivers. And this is across multiple industries, consumer-facing businesses, industrial space, etc. There's a bunch of things that one can do to increase operational efficiency, effectiveness, and revenue, increasing revenue with cross-selling, upselling, recommendation engines, etc., increasing automation, improving processes, reducing risk, customer churn, fraud, waste, and abuse, cybersecurity, lowering cost. There's a bunch of things that you can do in that regard as well. But because you've got data, there's also a lot of strategic value that one can unlock. And you can obviously make faster, better, more proactive decisions and try and automate some of that. You can do innovation collaboration, but you can also create new business models, new revenue growth models as well. So those are important. And I think for customer-facing businesses, it's really about that, and this is what this conference is also about, enhancing the customer experience, more targeted sales and marketing. And I think kind of end state around this is real-time, on-demand, digital, personalized service delivery and assistance and advice. We need to get to that world. I think people are expecting that with games and other things as well. People interacting with phones as well. You see some of the apps incredibly intuitive, and I think that's what they're expecting from big companies, to actually provide those kind of business and interaction and customer experience. That you've got a lot of information about me, so I expect you to actually know a bunch of things. So they expect context. We're working with some of the companies, financial services, where they send SMSs out, say for loans, whatever, no context. It doesn't know what was sent before. Data's in silos. Most companies that I work with and deal with, you can see that's a problem. There's no rapid access to all available data, and they're not bringing it all together. So I think that's absolutely critical to create that 360-degree view or insights about the customer. And then I think there's a few things that you can do in terms of reducing process times and costs. There is improving risk selection assessment, improving efficiencies. Well, there's a few things that one can do. And we do have a bunch of solutions around each of these categories as well. In terms of virtual assistance, risk and recommendations, churn, insight, and so forth. Even with employees, we've got one of our companies in the group is called the Talent Index, where we do human capital evaluation. You can actually do resignation risk prediction over 2-year, 3-year, 4-year periods. We're working with some companies where we've got employment data, and so that's interesting and exciting as well. But there's a range of things that one can do. We also look at digital transformation of businesses. And we're working with some of the corporates where we help them on this journey. I know normally it's like the PwCs, Deloitte, those type of companies help with that, but we're like an agile version of that. We also look at that and what your infrastructure should look like, and actually guiding you on this big data analytics maturity curve. The Industrial Data Corporation has got a maturity framework where they're looking at the 5 pillars of people. First of all, it starts with strategy intent, but then people, processes, data, and technology. And you can look at your maturity from that perspective for all parts of the business, going from an ad hoc state to an optimized state. And you can measure that on a monthly basis. And I've done that before, even when I was in General Electric, and also in other companies as well, where we've done this. And it's important. You can't manage, you can't measure. You don't measure properly. If you think about the insurance industry, just to make it more specific, there as well, we talked about the personal customer experience. The value there is redefining the value proposition to the customer. But there's a bunch of AI, a bunch of technologies that can be used to actually support that enhanced service. But then you can go to digital advice, where you're redefining that distribution. There's a few things here. Enhancing efficiencies, we've got automated augmented underwriting, and then reducing claims processing time and costs with robo-claims adjusters. So there's technologies you can apply. So this is on the insurance industry, but give you an idea, this is also relevant for banking and so forth. So it's really all about that 360-degree view, rapid access to all available data. And I'm not going to go too much technical around this. I just want to say the 3 things that I talked about: enable smart data for automated AI, automating AI, and then integrating into the business. I think it's very important to have a proper data lake, data warehouse in place that feeds your data science, predictive models, analytics, that you automate, and that is integrated into the business. And you can apply this to so many different use cases as well. And if you think about analytics, you can think about this on this whole scale. Obviously, it will be interesting if you look at what you do in terms of that, but there's descriptive analytics, that what happened, and diagnostic, why did it happen, discovery, what's hidden in the data, predictive, what could happen, so you can get a lot of value from that. But then you want to actually say, okay, so what? So what do I do with this information? And this is where prescriptive comes in, how to make it happen. And the cognitive part is more what to do, why, and how. So it's actually giving explanations for decisions. It's also reasoning with purpose, interact naturally. It's that kind of thing that you get with intelligent virtual assistants, and true context, semantic understanding of what customers are saying. So there's obviously more work to be done on that front, but these are kind of a spectrum of analytics that one can apply. So I'm going to quickly talk about a few use cases. And in terms of, if you think about customers, you don't want customers to churn, to lapse. And here is a very specific use case where, is this still good enough, the quality?
Yeah.
Okay, cool. Where we look specifically at funeral policies, and there's payment transactions. There's a lot of value that you can get from payment transactions. Just to give you an idea, so we build up credit risk and affordability models in the past for another company that's looking at wallet behavior and is looking at all direct records. There was no credit risk history, nothing like that. You actually build it up. You provide microloans, there's kind of microloans, but there's also insurance products and other things being serviced via that platform. And it's all done via feature phones as well. In the African market, and going out in Pakistan and Asia as well. But in this instance, this particular example, we looked at funeral policies for the main members, got a 94% accuracy rate on test data, so that's unseen data, not the training data, it's the test data. And once you've got something, accurate type of model like that, you can now predict, you can get new data in there, it will make some predictions that you can trust, and you get a confidence in that. So the cool thing about this, and I'll quickly explain before I show a bit more about the model, maybe still not great quality here, but anyway, some of the factors that went in here is looking at gender, looking at the planned region, looking at the age of the members, looking at the branches, looking at the premiums being paid, and the expected payment methods like CPN, cash, debit order, telecash, a few other easy pay, SASA, a few things there. Is the plan active or not, lapse or not? But also things like, for instance, the brand, what type was the brand, and also the plan category, plan type, and so forth. And this is the model, so it's 94% accuracy on the test data. But once you've got a model, you've got something powerful because you can obviously make predictions, but you can do also model analysis. You can extract information from that model as well. So you can look at the variables that's important in terms of lapse propensity. So in this case, it was plan cover and use term and those and so forth. You can obviously, if you use techniques like random forest, for instance, we use a range of techniques, whatever, horses for courses, the best type of techniques for the right things. You can uncover quite a bit of information. But this is kind of the model analysis you can do as well, which is cool. So if you look at the average probability to lapse, you can look at this by plan brand, and it actually shows you which of these brands is more likely to lapse. Well, the people that's obviously having those brands, and those are indicated there. But then you can also look at the plan category, and you can do the same thing, obviously, around your people, the demographics. If you look at the members itself, so males and females, this is category, we can know if they were males or females, but you can also see age. So you can see the young, between 13 and 37 years of age, males, they've got the highest likelihood of lapsing. So just looking at age and gender, but you can look at plan cover and plan active as well, and then look at plan brand and premium. So you can see, in this case, we're looking at the plan branch. So in this case, Beaufort West, Kroonstad. Sorry, I shouldn't name that. But anyway, so there's a few places where they were more likely to lapse. And if you look at plan premium, you can see also the premiums where they lapse, more likely to lapse as well. And you can do the same thing with use term, payment methods, etc. So just an example of that. And there's many use cases around this. So this is another one in the insurance industry where there was a 40% cancellation rate of policies issued within 90 days after sale. And again, we applied an AI solution around that, and the cost savings was around 100 million, 120 million per annum identified. So this is real possible things that one can do. Fraud detection, 70 million rand worth of fraud detection views across 3 schemes identified. And this was the specific thing they referred to earlier on in terms of mobile money use cases. So there's a range of things. Once you've got your data sorted out, access to all available data, you can create all sorts of predictive models, credit risk affordability. You can do anomaly detection, fraud detection, response modeling, reject inference. Obviously, segmentation is quite important because you can create models, but if you've got really good segmentation, you can create focus models for each of those segments as well. So that could help enhance your risk scores and affordabilities and all of those type of things as well. Yeah, this is just some of the benefits. I'll skip that. And yeah, this morning we talked about chatbots, so we're doing quite a bit of that. That's integrated into the omni-channels. We're working with that, integrated with messaging platforms. We're working with a big telecommunications company, well, I can't say names, but where we are implementing customer service chatbots. Not only, well, you can do it for a call center, but you can also do it via the public website. You can also do it via the messaging platforms, and you have a consistent way of doing that. One of the other areas is robo-advisors as well. So just something else. So as Cortex Logic, we are also going to put up, I think, Africa's first AI hedge fund. So we've got some state-of-the-art AI technology, and we are looking at robo-advisors that can connect to that, as well as to other customers that's interested in those type of things as well. So we are definitely, the financial services sector is quite an important sector for us. But I think if you look at intelligent virtual assistants, I think the context, history, profile, those things are very important. Deep integration to all data sources is very important. Domain expertise, multi-language, all of this kind of stuff is, and it's tricky to get this right if you don't have all these kind of pieces as well. We've also done things like personalized AI-based search and stuff, so maybe I'll skip that for now, but this is the trading system. And this is the human capital assets valuation, where you look at an employee and looking at the life cycle profiling. And you can look at, you can do benchmarking, you can do risk profiling, workflow alignment, human capital valuation. If you look at financial statements, it's typically you're looking at the assets, but people, I think EOH has got a saying, technology makes it possible, but people make it happen. So the people are still very important, even in the smart technology era. The way we work with machines and AI and all of that, I think jobs and tasks will change. We need to be very adaptive around that. But anyway, lots of challenges, and I think this type of solution is going to become more and more important going forward. And this is just emphasizing the point around rapid access to all available data. One place, any data, all data. If it's not everything in one place, then you want to do data virtualization. So as long as you've got access to all available data, I think that is the key thing. It'd be cloud, on-premise. They even talk about edge, fog, and cloud. And fog is not like a data center, but it's closer to the edge, closer to on-premise, and you can do some analytics on that front as well. And I think we will see that as well. You will see things like TensorFlow being deployed on phones, where you see, maybe you train it in the cloud, but when you do the deployment, it could be on the platforms and systems on site. So I think that's the world that we're moving towards. Okay, I'm going to skip this because this is more industrial space. You're not really into that space. IoT might be interesting for all industries going forward. We've seen this with retail and other things as well. So I think with AI and IoT, we'll create a smart IoT world. But I think we're moving to this kind of world in all industries, where you've got assisted intelligence, augmented intelligence, and autonomous intelligence. And assistance is where the nature of the tasks don't change, but the tasks are automated, and humans don't learn really there, but machines learn. And this is things like machinery, processes, factory, boilers, ovens. But when you get augmented intelligence, it's the nature of the task changes. You also see humans informing machines, and machines informing humans. And examples of that is like business strategy analysis using machine learning, or maybe in the financial and healthcare, smart clinical decision support. But when you move to autonomous, you also see the nature of the task change, but you see decisions, some of the decisions are automated, and machine learns continuously on that. And you get that with autonomous vehicles or smart investments and so forth. And I think there's a massive market for that in terms of creating that. So I think for how much time do we have? Well, this is great. I'm almost done actually, so it's not bad. So the last section here is just more about, if you think about your business, I think there's transformation catalysts to help generate value. And the question is, how can you actually create that value? And I talked about those 5 things in terms of strategy, intent, people, process, data, technology, which is pretty much represented on this curve. If you do apply that in the right way, you can actually bring it back. You can accelerate the path to value generation. That's really what it's about. So I think it's very, very important to create quick win solutions. You can obviously look at this big picture. I need to get my systems in place, but you want to demonstrate quick value and integrate it into the business. Measure the value, getting confidence in terms of these type of solutions, and then you can move on. So I think these words are very important. Demonstration of value and to operationalize. This is just Airbnb's example as well. They talk about how to scale data science for impact. And really, they talk about the voice of our customer insights to inform decisions about driving business value. Start right there. There's proactive partnerships with other teams in the business to drive the impact. Then thirdly, you move towards customer-driven decisions via disciplined, impactful data science process. Then you democratize data science AI throughout the company, and then you increase the ability to distill causal impact. So these are the things that some of these market-leading companies, as disruptors, are doing. And this is what I think the banks and other companies and corporates should also look at. There's journeys. I'm going to just skip some of this as well. Skip all of that. And then in terms of maybe just finally, I've mentioned the 5 things. You can actually measure from an ad hoc, opportunistic, repeatable, managed, and optimized state for each of these 5 pillars. And you can apply this to anything in any department of your business. And there's very specific descriptions from the Industrial Data Corporation's maturity framework in terms of what is the ad hoc state, what is the optimized state. And you can look at the key characteristics, what's the goals, what's the outcomes, and so forth. Okay, so that was the thing. I'm ready for any questions. So if you've got anything, let me know.
Any questions, any comments?
May I ask you to go back to a slide that you skipped over?
Yes, absolutely.
The one on the, what is the data scientist of today look like? Because I think one of our main challenges is resourcing. Right? The skills for this role is either very expensive, very hard to retain. In the first place, it's hard to find, but then hard to retain.
Yes.
So, who do we look for? So, if you can't find that perfect resource with R and Python and Hadoop and everything that comes as a package deal, who do you look for to upskill into that kind of career path?
I think it is okay. Yeah, I think it's very critical, very important. So there's 2 things about that. So the first thing is, I've also founded Machine Intelligence Institute of Africa because of that need. We need to network together the critical resources around data science, machine learning, and AI, and so forth. So if you go to the Machine Intelligence Africa.org website, you will see a community. There's more than 2,300 people already on that platform. Machine Intelligence Institute of Africa. It's machineintelligenceafrica.org. It's a non-profit organization, MIIA, and if you go there, you will see a bunch of resources as well. That's just an example. There's a few other organizations like that, but this is the one that I've just created a few years ago. And that was quite important for me as well, because obviously my whole career has been built in AI and machine learning, so I've got a whole network across the globe actually in that. But this is the MIIA community was great because I've actually got in contact with a lot of people that want to join Cortex Logic and work with us. So I think companies out there should try to plug into those kind of communities and organizations, and I think that's one area, the one thing that you can do. I agree with you, it's difficult. The people that we employ in Cortex Logic is across, because we do looking at end-to-end. It's not just AI, machine learning, data scientists. We even moved developers into a data science developer role. If you think about, you need to do in-memory processing, you need to work in Spark, you need to know Scala and those type of languages, then it might be easier for a developer that's interested in data science to move there. So those are things that I've done in the past to build up a team, and that's what we're doing here as well. So people are moving into different roles. I've got a few chemical engineers, physicists, people that's used to working with data, even PhDs in those areas, that's becoming data scientists. So you see that type of, maybe you've got an actuarial background, you come into that area. There's also the concept of citizen data science, and the tools are also becoming more automated and easier. We talk about auto ML, auto machine learning, which actually makes it possible for people that you don't need to really know Python and R. You actually work with these kind of things. You've got more domain expertise. You can maybe embrace these kind of tools. So you can do things like that as well. So there are tools to actually supplement, so it helps a bit. But you would still need AI machine learning people, because you want to create end-to-end solutions, and those auto ML won't solve all the particular problems, because we're generating so much data, structured, unstructured data. There's so many application opportunities to unlock value. You need all the right people. So the people that we employ is data architects, data engineers, BI developers, BI analysts, software developers, to integrate this into the business. so integration specialists, AI machine learning data scientists. So a whole spectrum of people that can actually create that solution. And we work with companies where we help make that whole. So basically, companies got different strengths. So if you are weaker in data engineering, or maybe people that can work with in-memory processing stuff, we can fill those gaps, and we can work with the companies to actually to make it whole, so that you can actually create those end-to-end solutions. So what I would recommend is that one slide where I talked about collaborative innovation. I think it's difficult for some of the corporates to attract top talent, because we are also attracting that because it's interesting for people. I spoke to the CIO of, I'm not going to mention names, but of a few CIOs as well, and they were asking about this problem, and I just said, well, it's easier for us to attract top talent.
Banks are not sexy, are they?
What's that?
Banks are not sexy.
I don't know, but it's difficult. I don't know, but you do multiple things. It's difficult. So you've got that challenge. I do have this slide that talks about creating the best AI data science environment for top talent. So cultivating the richer data in your sector, maintaining an executive spotlight on their work, providing state-of-the-art data platforms. Those are things that one can do. That's also important as part of that. And I think it's very important to forging strong paths to operationalize. But I would really, to help fast track and maybe to learn, I would say partnering with some AI companies. There's unfortunately not a lot of really true AI companies in this country. My first AI company was the first one sold to a multinational on the African continent. Things have changed quite a bit. I think we live in a new era. You see a lot of new startups, and there's some really good talent, some good companies coming to the fore. And I also see some good stuff. I remember in Standard Bank, there's Michelle Gervais is doing an awesome job. I know her well, and she used to work at Time, I think, bank as well. But so there are some good initiatives going on. But I would definitely advise collaborative innovation, learn from that. Yeah. In the end, it's a business. You want to operationalize. So, yeah.
Any further questions?
Yeah. Sorry. We've got still. It's.
Are we done?
It's still time, but yeah. Any other questions? Yes.
Okay. Yes.
So, what if your data is a mess and you don't have quick access to structured and unstructured data, but you want to start doing some cool things? What's the best way to start?
Yes, so you've got to sort out that mess. So I would look at it, it's like burning a candle on two sides. So one needs to have a strategy in terms of sorting things out, your data lake, data warehouse, structured, unstructured data. This is what we also do, because we realize before you get to the sexy stuff as well, you want to figure that, you need to sort that out. So you can have a broader plan to figure that out. But what I would normally advise is also look at quick wins at the same time. Because even within that framework, you can create quick win solutions. There's one guy, I think one of the mining companies we work with, talks about little pools in his data lake. So you can still, as long as you've got access to all available data, you can create quick win solutions where you actually show the value. And I would definitely, that's why we go with both approaches. If a company's got it, because it's going to be very important, if you've got it sorted out, you've got the multiple AI applications you can apply that you will have, the returns would be enormous if you do it right. So, yeah. But if it's a mess, roll up the sleeves.
Sort the mess out. One more question? Any comment?
Yes.
Sorry, I wanted to understand, and I tried to always search for this definition, and I haven't been able to figure it out. What is the difference, in an easy way, between machine learning and deep learning?
Yes, I actually have a slide that's showing that, and I skipped very quickly over that. And I don't need the slide, but I'll just have the visual behind. Machine learning, deep learning. Okay, this is your slide. So machine learning is a very, very key part of artificial intelligence, and it's basically it's really all about data-driven. It's learning from data. So when you learn from data, it's machine learning, and you get a range of different techniques. There's a whole range of techniques. Deep learning is just a subset of machine learning. So again, learns from data, but it's just a specialized machine learning, because what it does, it's actually doing something that your brain is doing. If you look at your visual cortex, I think I've got the slide here, but it's actually going through layers of abstraction. So the first layers are just trying to figure out the corners and little segments and things. The next layers maybe construct, say it's doing face recognition, doing a little nose or a mouth or ear or little pieces, and then the next layers would actually construct the face, for instance. You might have many layers in between, but to create that type of stuff. So deep learning really works like that. It's really, that's why you can work with raw pixel data. So you can just give it pixels, and it will actually go through all of that to get to facial recognition or whatever you want to do, image recognition. And we've got now the computational resource to do this at scale. So you can, which was not really possible, say a decade or two ago. But yeah, so it's the official definition: model high-level abstractions data by using model architectures composed of multiple non-linear transformations. And basically, as you go through layers, it's not linear; it's non-linear transformations because it's non-linear. So it really boils down to that. You get a range of different things, but yeah.
So would it be applying multiple machine learning techniques or not?
No, you can.
It's a different technique.
No. So it's the same. It's like you still use backpropagation to create. You have a structure, architecture is just much bigger, and that you can just go through these layers. And with backpropagation, typically how it works, you give it input data, and basically what it does is going all the way up, and then it actually generates the error. And it compares to what the output should be, and then backpropagates the error, but it does it through all those layers. So machine learning is the same, but you also do that with deep learning. You can have a hybrid where you've got multiple machine learning techniques. That happens as well. But deep learning is really, it's like, well, you get different types of deep learning. It depends on the structure and stuff. But that's the essence of that. It's really just a way to deal with abstractions.
All right.
Okay, cool.
Thank you very much.
Pleasure.
Thank you. I love